friends, so today we are gonna learn a new concept which is called as Gauss elimination method. Now what is Gauss elimination method and why do we use Gauss elimination method in mathematics? So basically Gauss elimination method is used to solve the simultaneous linear equations. So from school days we have seen the many methods to solve simultaneous linear equations like Cramer's rule or by using the simultaneous equation method. Similarly, by using Gauss elimination method, you can still solve all simultaneous equations given. So how do we do this? For that, let's assume some simultaneous equations. So let's say a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z is equal to d2 and a3x plus b3y plus c3z is equal to d3 are the three simultaneous equations. So here I am considering three simultaneous equations with three variables, but you may have the 4 variables or 5 variables and so on. Now what exactly Gauss elimination method does? So it uses the approach of elimination of one variable at a time. So here when we solve this, so one variable will be eliminated. Let's say first x will be eliminated, then y will be eliminated, and in the end z will be eliminated and we will get the values. At the same time, Gauss elimination method can be done by using matrix form. So here guys, we are gonna use matrix form of Gauss elimination method. Now what is the matrix form? So for that we have to convert these given equations in the form Ax equal to b, where A is a matrix of coefficients, so where all the coefficients of x, y and z will come. So here I will say coefficient matrix. Next, x is called as matrix of unknowns, or I'll say variable matrix. So these are the unknowns which we have to find out. So here in this x, y and z will come, and in the end b is matrix of constant which are present on the right hand side. So I'll say it is constant matrix. So to solve the given simultaneous equations by Gauss elimination method, we always convert the given equations in matrix form, like Ax is equal to b. Then we will reduce the matrix A by using row transformations and we will convert it into upper triangular matrix. So here I will say reduce A to upper triangular matrix by row transformations only. Now whenever we are applying any row transformation on A, at the same time we will apply the same row transformation on matrix B. So after certain steps, that A will get converted into upper triangular matrix. Now what is upper triangular matrix? So let's see here. So upper triangular matrix is a matrix in which the elements below the leading diagonal are 0. So let's say this is a matrix of order 3 by 3. So the elements below the leading diagonal. So this is the leading diagonal. So the elements below it, that is here 0, then here 0 and here 0. So if we get these three elements at 0, then we say that matrix is upper triangular matrix. These elements can be non-zero. I will say, let's say A, B, C, D, E, F. So we just have to make these three elements 0 so that it will be converted into upper triangular matrix. And once A gets converted into upper triangular matrix, we have to stop the operation and then again we'll convert the matrix form into equations form, and if you'll see, then from the last row we have made two elements as 0, so we will get only last element, and this last element will be the coefficient of z, because x and y coefficient will be made as 0. So from this last row we will get value of z, from the second row we will get equation in terms of y and z, so we will put that value of z into the second row and we will get value of y, and once we get y and z we put in equation number 1 to get the value of x. So by using this method we can get the value of unknowns, that is x, y and z, by Gauss elimination method. Now to understand this method we will take one example. So let's see here, solve by Gauss elimination method. Now there are 4 equations are given and 4 unknowns are there. So let's start with the matrix form. So here, as I said, I will convert it into the form Ax equal to B, where A is coefficient matrix, X is matrix of unknowns and B is constant matrix. So this will become 3, 6, 5, 2. So I am taking the second equation first. So guys, you can take any equation anywhere. So I have taken the second equation first. Next here we will get x, y, z and w as the unknown, whereas on right hand side we will get the constant matrix. So here the constant is 2, I will write it over here. Next let's take this first equation. So it will be 2, 5, 2 minus 3, and it is 3. Then 4, 5, 14, 14 and 11, and this is 5, 10, 8, 4 and 4. So this is the first step where we have converted the given equations into the form Ax equal to B. Now let's start with the row transformations and convert this given matrix in upper triangular form. So for that, what we want is, we want this element. So see, this is the leading diagonal. So the elements below leading diagonals are this 2, 4, 5, 5, 10 and 8. So you have to make all these elements 0. So how we'll do it? So guys, what I'll do is, for simplicity, I'll make this 3 as 1. So to make it 1, I'll subtract this row 2 from row 1. So here I'll say by R1 minus R2, and we'll write the result in row 1 again. So here we will get 3 minus 2, 1, 6 minus 5, 1, 5 minus 2, 3, 2 minus minus 3, that is 5. Next, remaining elements as it is. Here 2 minus 3, that is minus 1. Now here we got 1. So what I'll do is, I'll do R2 minus 2 times R1. So automatically this element will become 0. Next I'll do R3 minus 4 times R1 and R4 minus 5 times R1. So these 3 elements will become 0. So now I will write by R2 minus 2 times R1, next R3 minus 4 times R1 and R4 minus 5 times R1. So here we will get, so first of all R1 will remain as it is, so 1, 1, 3, 5 as it is. Next, this matrix of unknowns will remain as it is, that is x, y, z and w, and here the first element will remain as it is, that is minus 1. Now let's start with the first operation, R2 minus 2 times R1. So if I'll do 2 times of R1, so this will become 2, 2, 6 and 10. Let's subtract it from row 2. So 2 minus 2 we will get 0, 5 minus 2 we will get 3. So here I will write 0, 3. Next 2 minus 6. So 2 minus 6 is minus 4 and minus 3 minus 10. So it is minus 13. So here I will write minus 4 and minus 13. Next we will do R3 minus 4 times R1. So 4 times of 1 will become 4 and 4 minus 4 is 0. Here 5 minus 4, that is 1. Here I will say it is 0, then 1. Next 4 times of this 12, so 14 minus 12, that is 2, and here 4 times is 20, so 14 minus 20 is minus 6. So we will get 2 and minus 6. Next R4 minus 5 times R1. So R4 is this, minus 5 times R1. So 5 minus 5 is 0. This is 5. So 0 and 5. Next here 5 times is 15. So 8 minus 15 is minus 7. This is 25. So this will be minus 21. So here minus 7 minus 21. Now guys, we have done these operations on matrix A. Similarly we will do it on matrix B. So for matrix B, R2 minus 2 times R1. So R2 is 3 minus 2 times R1. So this will become minus 2 and 3 minus minus 2 is 5. R3 minus 4 times R1. So R3 is 11. 4 times is minus 4. We'll add it. We'll get 15. Next R4 minus 5 times R1. So 5 times is minus 5 and 4 minus minus 5 is 9. So here we got this matrix. So you can see here that I have made these 3 elements as 0. Now we have to make this 1, 5 and minus 7 as 0. Now how to do that? So what we'll do is, here we will subtract this row number 3 from row number 4, but before that we'll multiply this row number 3 by 5. So here I'll say by R4 minus 5 times R3. So you can see here we can get 5 and 5 minus 5 can become 0. So here I'll say by R4 minus 5 times R3 we will get 1, 1, 3, 5, 0, 3 minus 4 minus 13, 0, 1, 2 minus 6. Here we will get 0. 5 times of R3, that is 0. Here 5 times is 10. So minus 7 minus 10 is minus 17. And here the 5 times of 6 is minus 30. So minus 30, and we have to subtract, so that will become plus 30. So minus 21 plus 30 is 9. Here we will get X, Y, Z and W. Next, here we will get minus 1, 5, 15. Now we will do R4, that is 9 minus 5 times of 15. So 5 times of 15 is 75. So 9 minus 75. So we will get negative 66. So we got this element also as 0. Now we have to make 2 more elements as 0, that is this 1 and minus 17, and after that it will be converted into upper triangular matrix. Now to make this 1 as 0, I have to either subtract R1 from R3, so 1 minus 1 will become 0, or this is R2, so R3 minus 1 by 3 times R2. But guys, if I will do R3 minus R1, then you can see here that we have 1 here, and due to that here we will get negative 1. So this 0 will again become non-zero element. So what we will do is, we will make this 3 as 1 and then we will subtract this R2 from R1. So here I will say by R2 minus 2 times R3. So here we will get 1, 1, 3, 5 as it is. Here 0, 2 times R3. So this will be 2, 3 minus 2 is 1, 2 times R3, so 2 times will be 4, and minus 4 is minus 8. Here 2 times minus 12, this will become minus 1. Next as it is 0, 0, 1, 0, 2, minus 6, minus 17 and 9. And this is x, y, z, w. Here we will get minus 1. Here 15 2s are 30. So 5 minus 30, that is minus 25, 15 and minus 66. Now you can see here that I have made this R2 element as 1. So I can subtract this R2 from R3. So by R3 minus R2 I will get here 0. So here I will say by R3 minus R2. So we will get first row as it is. So 1, 1, 3, 5. Second row as it is 0, 1, minus 8, minus 1. Here x, y, z, w. Now minus 1 and minus 25 as it is. Now R3 minus R2. So here we will get 0, 0, 10 and minus 5. So 0, 0, 10, minus 5. Here we will get 25 and minus this minus 25. So 40 here we will get. Last row as it is, that is 0, 0, minus 17, 9 and minus 66. Now the only last element is remaining, that is this minus 17, and we have to make it as 0. Now to bring 0 here, we will multiply this row 3 by 17 upon 10, so that here we will get 17, and then we can add it with R4 to get it 0 over here. So here I will say by R4 plus 17 upon 10 R3. So by doing this we will get 1, 1, 3, 5, 0, 1, minus 8, minus 1, 0, 0. Now here we will get 10 minus 5. This x, y, z and w as it is equal to minus 1, minus 25, 40. Now here we will get 0, 0. Now 17 upon 10 into 10 will be 17. If we will add with R4 we will get 0 here. Here 17 upon 10 into minus 5. Here I will do it in rough. So we will get 17 by 10 into minus 5. We have to add this result in 9. So here I will write 9. So we will get 9, and this is 5 ones are 5 twos are. So I will say minus 17 by 2. So this is 18 minus 17 upon 2. So I can say it is 1 by 2. So here I will say we get 1 upon 2. Next, here we have value 40. So what we have to do is 17 upon 10 into 40, and then we have to add it in row 4, that is minus 66. So see here it is minus 66 as it is. 10 ones are 10 fours are. So here we will get 17 fours are, that is 68. So plus 68, and the value will be 2. So here I will write it is 2. So now here we got the upper triangular matrix. Now let's convert this upper triangular matrix or this form Ax equal to b into equations to get the final answer. So from first row we will get the equation as 1 into x, that is x, 1 into y, that is plus y, 3 into z, that is plus 3z, 5 into w, that is plus 5w, is equal to minus 1. From second row we will get 1 into y, because coefficient of x is 0. So 1 into y is y, minus 8z minus w is equal to minus 25. Next 10z minus 5w is equal to 40, and the last equation is 1 by 2 w is equal to 2. So now if we want to find out the value from here, we will get, by sending this 2 on the right hand side, w equal to 4. Now we'll put this value of w here in the equation 3. So here we will get 5 into 4, that is 20, minus 20 will shift to the right hand side, will get plus 20, that will become 60. So 10z is equal to 60, or I can say that z is equal to 6. Now we'll put this value of z and w in above equation. So here we will get minus 8 into 6, that is minus 48, w here, so this is minus 4. So minus 48 minus 4 is minus 52. If we'll send it here, that will become plus 52, and that is nothing but 27. So we get value of y as 27. And when we put all these three values in equation 1, we get 27, 3 into 6, that is 18, so this is 45, and 5 into 4, that is 20, that is 65. And when we shift this 65 on other side, that will become negative 65, and we will get x as negative 66. And guys, you can see here that we got all values of unknowns, that is x, y, z and w, by Gauss elimination method. Thank you.